Hello students, today I will talk about interfacing. In first half of our course, we have studied about the core architecture of LPC 1768, ARM Cortex-M, that already we have completed, that module we have already completed. So that was pertaining to the overall internal core architecture of our Cortex-M microcontroller or processor. So here in front of us, there is one kit. Now in the second module of our study, we will focus on interfacing. So here on the kit, as you can see, the overall kit in front of you. So here I will describe in brief the elements out of which it comprised of. So here on this kit, as you can see, this part here, this part, this one is core architecture, is a core, system core or microcontroller. So this chip is microcontroller. This chip is microcontroller. It comprises of 100 pins. So you can interface the core through those 100 pins. Those pins can be used as input pin if we will deal those pins through general purpose input output or output pins. There are several other functions which a single pin can be used for. In total, a single pin can be used for 4 purposes. Out of those 4 purposes, one purpose is to use that pin as general purpose input output. Once if you are using that pin as a general purpose input output, in that you can use it as input pin or output pin. So either the 0 value could be there over the pin or 1 value. Our core function on the voltage of 3.3. The whole kit requires a voltage of 5 volts. Then it comes down to 3.3, and on 3.3 voltage, our core functions. These specifications are only for this kit in Cortex-M LPC 1768. So this kit requires an input of 5 voltage. So here you can see the power supply. So here you can see the power supply. This module is for power supply. So this power supply, you will provide the DC power supply of 5 volt, and internally the architecture, core microcontroller will use 3.3 voltage. This is regarding the power specifications of this kit. Then when you have to interface this kit with your system, so suppose there is something in system, or there is something when you want to interface this kit with your system, outside some processor you want to interface it with, then we will use this UART serial interface for that purpose, or we can also use USB interface also for that matter. Then there are several other modules. Every other module apart from this core microcontroller is known as peripheral unit. So there are several peripheral units. Over a period of time, we will study and understand those peripherals and their interfacing with our code. To interface your peripheral with your core, you require pins. Now, how to use those pins? That is our task. That is the aim of this lecture, to understand that how to actually interface. What is that logical construct which we will use to interface these peripherals, external peripherals, with our code? That is our ultimate aim. And to understand this concept, so let me just brief you about the peripherals which we will study over a period of time. This is general purpose LEDs. So first, initially, we will understand how we can control, because core microcontroller is for, as the name suggests, it is to control the peripherals. How you can control the peripherals which you will interface it with. So suppose if we are interfacing this general purpose LEDs with our core, so you can control the LEDs. How you can control the LEDs? As per your requirement, to you can turn on and off the LEDs. So here in our kit, 8 LEDs are there. So we require 8 pins. Those 8 pins we will connect. So these are the connectors. So this connector is for general purpose LEDs. So this connector has 10 pins. 8 pins out of these are for LEDs and 2 pins are for power supply. One is to ground and another one is for power supply. Likewise, we can connect, means we have 4 connectors. C and A, this one is C and A, where you can see C and A. This is one connector which will connect uh, these core pins, microcontroller pins, with our peripherals. This is C and A. 8 connectors here, means 8 pins, total 10 pins, but 2 are not going to be used. Those are for power supply. One is to ground and another one is for VCC, means plus 3.3 voltage. Likewise C and B, and then C and C and C and D. So it will not provide the connection of all 100 pins. So this kit is only for demonstration purpose, that how we can connect the core pins with peripherals. So all the pins we can't use. We will see that how to even use the pins. So what is the logical construct? The logical construct of ports, and every port has certain pin numbers. Those particular pins we have to use for particular purpose. How that logical construct we will use for that purpose will look in future. So that is all about connections. Likewise, here there is an LCD that also will study. Then here is 7-segment display. This is 7-segment display, 4 units, one 7-segment display, second, third, fourth. And there are several other peripheral units which we will study. Then keyboard. This is keypad, 16 keys. So this is 4x4 key matrix. That also we will interface with our core. So whenever you will press, so suppose if you press this key and you want that whenever you press, your system should understand it as A or 1 or anything of your desire which you want your system to understand. So for that purpose, you will write C programs. That is called embedded C. So in embedded C, we will write those programs. Then after writing that program, we will compile, link those programs, and then convert those programs into hex file. Those hex file later on through this interface, serial interface. So all that we will do in our system using Keel software, microvision Keel software. We will write our code there, and after compiling, linking, we will create the hex file. That hex file, using other software, we will load to our ROM in core. So whenever you will write that hex file in the program memory of ROM uh, of this core, then once you will start the kit, once you will give the power supply to this kit and connect all the peripherals correctly, that is important, that how will you connect the interfaces, and how you will interface, and for that interface obviously you will use port and the pins. How will you connect those pins to that particular peripheral unit? That is important. After doing that, once you will give the power supply, then the program will run. Then your core will execute whatever be there on the ROM. That is about. Then in the subsequent classes, we will interface ADC, that is analog to digital converter, because our core can only understand digital things, 0 and 1s. But anything in reality is not digital. Suppose if we have to interface a temperature sensor. So temperature sensor will first sense in analog form. That analog need to be converted into its equivalent digital form. So for that purpose, this you can see AD 0.4, AD 0.5. So this analog to digital converted module we will use, that we will interface with our core, and whatever be the converted value, that later on we will write on our LCD. So that's how we have to interface. First we will interface our ADC with core. That core will then instruct LCD to display that. So it is all about controlling the peripheral. So your core you have to use in that way, so that sometime it will take input. Certain pins will act or function for taking inputs. Certain pins will function for writing certain output to it, and you have to write it in certain logical way so that your peripherals can understand that, and your core can also make meaning out of that. So for all that to happen, we require one logical construct, that how we will write, how other peripherals would understand all this, whatever we are thinking of, how we can do it. So for that to happen, these 100 pins, uh, they're divided into, to use these 100 pins, somehow we have to name these pins, and then only we can start writing the code out of that, which both our system code as well as the peripherals can understand. So for that, logically, all these pins are divided into ports. We have 5 ports in number. Now we'll go to our presentation. So we have in total 100 pins on each side of this chip. We have 25 in total, 25, 25, 25, 25. So in total 100 pins are there. These 100 pins, out of these 100 pins, every pin we can't configure and use as general purpose input output pin. Out of 100 pins, only 70 we can use for input output configuration. Then this core comprises of 512 KB flash memory, 64K static RAM, 8K ROM, and 100 pin chip is there out in front of you. These are all in chips. So your microcontroller and all these things are on the same chip. That's why microcontroller, the speed is more, because there is nothing in between buses which will bring the content from flash memory, static RAM, ROM. So there is no in between bus interfaces and all. So even though that is there, that is of high speed because everything is on the same chip. That's the difference. Already we have studied that difference, that what is the difference in normal processors and microcontrollers, because those are on-chip devices. So all these things are on chip. So these are not the peripheral units which need to be interfaced through buses. And even the buses which do exist are of high speed. So that is all about the pin configuration of your LPC1768. Now to use these pins, we have 5 ports in place. So that is logical. That is all just for the programming purpose, that how we will make good use of these pins, how we can write. So something logical should be there over this physical. So for that purpose, we have 5 ports in place, port number 0, 1, 2, 3, and 4. Every port has 32 logical pins. 32 logical pins. It is not the physical pins because ports are not physical in nature. Ports are also logical. So every port has 32 logical pins, and then these logical pins, every pin we will not use. Some pins are reserved. So every port has its own configuration, that which pins out of the 32 which it has we can use. So here you can see the port 0, pin number 12, 13, 14, and 31 are not available. We can't use these pins. So port number 1, 2, 3, 7, 6, 5, 11, 12, and 13 are not available. These pins are not available. Likewise, in port 2, only pin number 0 to 13 are available and rest are reserved. In port 3, 25 and 26 are available, rest are reserved. In port 4, 28 and 29 are available and rest are reserved. In total, out of 100, in physical, 70 GPIO pins can be used. Because if you will make a calculation, rough calculation, then 5 ports are there, 5 into 32 pins. So it will give us around 160. So we have in place 100 pins. Those 100 pins, physical pins, we can't map to 160 logical pins. Even though that is not our requirement. Our requirement is somehow to map even those 100 pins, physical pins, to only 70 GPIO pins. Only 70 GPIO pins are available, which can be configured as GPIO. You don't have to worry or remember too much, but that much understanding is enough for us that every port will not provide us all the logical pins. Some pins are reserved that we have to look back in our appendix or anywhere where this configuration is given. So somewhere we have to look that port 0 will provide the functionality corresponding to which pin, and for which pin it is not providing the functionality. That is one thing which we have to remember while dealing with ports and pin. Now, how to represent it? How we will represent this? What is the naming convention? So we have port, and inside port we have pin. So how we can represent it? P x dot y. Here x, here you can see x means port number and y means inside that port which pin we are targeting and which pin we want to name. That's how, like suppose P 0.7, that means port number 0, pin number 7. P2.11, pin number, port number 2, pin number 11. In this way, we can refer to a particular port and its corresponding pin. Now, as I mentioned earlier, every pin has 4 functions. Every pin can be used for 4 functions, but at a time, it is used only for one function. So if it is configured for one function, at that time, other 3 functions we can't expect from it. System can't expect those 3 functions from it. So out of 4, only one at a time we can take that function. Now, why is it necessary? Because our pins are limited. That is always a trade-off, because we want several functionality out of our system core, but for interfacing purpose we have limited pins. So we have to multiplex each pin for several functions. When I'm using the word multiplexing here, means one pin can be used for several purposes, but one at a time. So there you require multiplexer to select the functionality associated with that pin. Now 4 functions are there. Each pin can be used for 4 purposes. How your system would understand now your pin is configured, or now your system should understand that pin into a particular functional context. How we can ensure that thing? We can ensure that thing through multiplexer. That is the hardware part. We require multiplexer. But out of 4 functions, one function we want to represent. So we have to configure that pin for that function. How we can configure that pin? There is one additional register for that purpose. That additional register is pin select register. So we will directly head on to pin select registers. Now 5 ports are there. Those 5 ports each port comprises of 32 pins. Some pins are reserved, but that is another part of understanding. Here we will focus on all the pins, 32 pins. Those 32 pins can be configured in 4 ways. So individual pins can be configured in 4 ways. 4 functions it could be associated for. Out of those 4 functions, I want to name the first function, that is for general purpose input output. That pin can be used for general purpose input output. We don't have to understand all other 3 functions now in detail. So for that, I'm terming those functions as function 0 is for Gpio, function 1, function 2, and function 3. Now how to configure it? So every pin require how many bits? Because every pin can be configured into 4 ways. So how many? So if there is one multiplexer which has to select. So here you have a multiplexer which is of size 4 cross 1, because 4 inputs are there, and it has to select only one input. That input corresponds to our functions. First function is default function, that is Gpio, general purpose input output. If we want to use that pin as general purpose input output, that is the default function. Then there is a first alternate function, second alternate function, and third alternate functions. So every pin can be used in 4 ways, but at a time your multiplexer will select only one. So now it requires 2 select bits. Those select bits will come, you have to write somewhere. So when you will start configuring your pins, so for system to understand, we have to configure these registers. So pin select is one of the register. So this register will hold these port pin function selection bits, these two bits. So suppose if we want to use port number 0, pin number 3, corresponding to port number 0, pin number 3, we require two select bits for system to understand. Those select bits we will write somewhere. As a programmer, as as to program our system for a particular purpose, if we want to use port number 0, pin number 3, and we want to use it for general purpose input output or first alternate function, second alternate function, third alternate function in corresponding pin select register, and all these registers, pin select registers, and every subsequent registers will understand all are memory mapped. So our system comprises of 4 GB memory. So everything is mapped inside that 4 GB. It is not a separate memory, register memory is not separate. So out of that 4 GB, somewhere these registers will be located, and those values are fixed, those memory locations are fixed. So system can understand if we are using pin select 0 register, pin select 1 register, pin select 2 register, in total 10 pin select registers are there. Later on we will come to a conclusion that only why 10, 11 pin select registers are there. What is the purpose of every pin select registers? Every pin select register is related to some port number and its particular pin. So to configure those particular pins, we require that pin select register. In that pin select register corresponding to every pin, we require 2-bit positions in the pin select registers, because select out of these 4 functions, we require 2 bits. Then straightway, once your execution will start, system will look for the pin select register, particular pin select register, and provide those 2-bit positions, and directly connect those 2-bit positions, take those 2-bit positions and provide or feed in to these select bits. That is all about the idea of writing those values in a particular pin select registers. Now we will see the pin select registers in detail. So what we have to write, if we want to select the first default Gpio function, then we have to write over to the bit location in a particular pin select register 00 on those 2-bit locations. 01 for first alternate, 10 for the second alternate, 11 for the third alternate. We'll go in detail particular to 01, 10, 11 in subsequent videos. But here by default, because even if you will not write anything to these pin select registers, obviously the value would be 00. So by default, if you just want to use those pins as general purpose input output, you don't have to write anything. Explicitly, you don't have to mention, because already by default the value is 00 there. So your multiplexer will take 00 and will configure that particular pin as general purpose input output. So here we are using port number 0. In the demonstration, you can see port number 0, pin number 0 we are configuring. So in a particular pin select register, your multiplexer will take these 2 inputs. Now we'll see that your multiplexer will take these 2 input values, those 2-bit positions will come from which pin select register. That we will see. In pin select, so total, how many pin select registers we do require? So in total, if you target any port number, suppose port number 0, we want to understand that how many bits in total do we require to configure all the pins corresponding to port number 0. So port number 0 has 32 pins. 32 pins require 64 bits in total to configure individual bits. So total 32 bits are there. One individual bits require two bit positions in pin select registers. So here, as you can see, port number 0, pin number 0 corresponds to two bit positions in our pin select register. So in pin select 0 register, port number 0, pin number 0. But as you can see, every register comprises of only 32 bits. And here we require 64 bits in total. So in total, how many bits, how many total number of registers we require? Two registers we require. So pin select 0 will hold the configurations corresponding to pin number 0 till 15. So in total 16 pin configuration will be there in pin select 0. Later on, for port number 0, pin number 16 onwards till 31, we require pin select 1 register. Likewise, port number 1 has also 32 bit position. It also requires two pins. So port number 1 information regarding the configuration of the functions will be in the pin select register 2 and 3. In subsequent way you can see, so in total you require 10 pin select registers. One port will require two pin select registers. Numbering you can see. So pin select 1 will hold the information, configuration information for pin number 16 to pin number 31. Likewise, pin select 2 will hold from pin 0 to 15 corresponding to port number 1. Pin select 3 for 16 to 31. Likewise, pin select 4, 0 to 13 for port number 2. Pin select 7, 3, 25. So in this way you can see. So that is about pin select register. So first, our aim should be to understand that how to configure any pin for a particular function. It is not just for general purpose input output, because even if you will not do or write anything to general purpose in these pin select registers, already by default these pins will be used for general purpose input output. But if you have to configure it for some other specific purpose, suppose for UART purpose, for serial communication, you have to configure it, then the function will not be by default what we are using for general purpose input output. Then function will be different. Then we have to write some other value corresponding to that pin. Then 00 would not suffice. Some other value we have to write. That value we have to check from the table, from the port table, that this port will provide these functions pertaining to these particular pins, because every pin you can't use. First of all, some pins are reserved, some pins are usable. Out of those usable pins, every pin you can use for four functions: function 0, function 1, function 2, function 3. Function 0 is by default. Even if you will not write, obviously that thing you can use as general purpose input output. But apart from that, if you have to use it for some specific purpose like UART, PWM, ADC, those are all the things which we will use later on. So for that function to configure in a particular register, in a particular pin select register corresponding to particular port and its corresponding particular pin, we have to configure our pin select register. So that you can configure the function. That is all about the pin select registers. Understanding about pin select register is very much important, because any program, once you will start writing, first you have to think about which pin will you use. Once it is confirmed that these pins you will use, later on you have to figure out to which I mean, first you will understand that to which pins will you use, and later on you have to decide on the parameter that this pin will be used for what function. Once these two things are decided, then you will understand that this later on, then you will figure out that a particular later on then you will figure out the particular pin, I mean pin select register. So that pin select register, I don't want to repeat, that is even confusing. Here once again you can see the pin select 0 register will be used for port number 0, pin number 0 to 15. Pin select 1 for port number 0, 16 to 31 pin select 2, 3, 4, 5, 6, 7, 8, 9. Likewise, for us, pin number 0 to 9 will be sufficient to understand. Pin select 10 will be used for some other purpose. It is for some A2 as some other purpose it will be used. Here in pin select registers, what exactly we are doing? We are configuring a particular pin for a particular function. So in total, every pin can be used for 4 functions. So system to understand that which function at a time we are using the pin 4. So to represent or to configure that thing, we are using pin select registers. That is in simple way we can understand the functionality regarding pin select registers. Now we will go ahead and see that once you have defined the function corresponding to a particular pin, here suppose we have configured the pin as general purpose input output. Now how to manage the ports? If we have configured the pins in that particular port as GPIO pins, now how to actually manage those pins? How to manage that port? Management means if those pins are as GPIO, general purpose input output, how system will understand that a particular pin has a direction of input or a particular pin has output direction? How will you present that information to the system to understand? For that purpose, we have FIO DIR register. These are in total 5 registers to manage a particular port. So to manage a particular port, we have FIO direction, first register. Once you have configured the pin using pin select register as GPIO, so by default also, if even you will not do anything by default also, that pin is GPIO. Once you already have done it, the second part is system should know whether it is input pin or output pin. To make a particular pin as input, so we have FIO direction register. So it is of 32-bit, and in every port in total there are 32 pins. So corresponding to every pin there is 1 bit position in this register. Corresponding to port number 0, suppose for example we are using port number 0, so it has its own FIO direction register. So every port has these all 5 registers in place. Port number 0 has its own FIO direction register. Port number 1 has its own FIO direction. Likewise, every port has their own FIO direction registers. Likewise, all other registers they all have in place. Now in FIO direction, we will only represent the directions. While representing the direction, 0 means input, and if anything you have to mean, so 0 is by default. So even if you will not write, everything will come as 0 initially. So by default, every pin is input pin. If you have to make a pin as one as output pin, then you need to represent it through writing 1 to a particular bit position. Suppose in port number 0, pin number 31 we want to make as output pin. So in FIO direction register on the 31st bit location from left side, we will number it from 0 onwards, subsequently 1, 2, 3, 4, 5, 6, and till 31. The 31st bit location should have the value 1, and only your system, the core, can understand that this pin is used for Gpio, and inside Gpio, the direction is output direction. That is one thing. Then, if suppose in that pin, in that port, we want to know what is there on all the pins. So in one shot, we want to know the values which is right there on all the pins. In that situation, FIO pin would be handy for us. So corresponding to that port, FIO pin we will read. So it has 32 bit. So whatever be there in those 32 bit locations, whatever be the value, that is the actual value over those pins. That is the actual value over those pins. So that is one thing. So if we want exact value, then FIO pin will be handy for us. Now, FIO pin can also be used to change the value. Suppose we want to change the value, some other value. So at a time, certain value is there. In the subsequent time, we want to change the value. Now we want to change the value. So prior, some value was there over the pin. That also we can read through FIO pin. So if you will read FIO pin, what the value will get, that is over those pins currently. Now we want to change the value. So the current value we want to change with some other value. So 32 bits we will take in some other register, in some other variable. Those 32 bits exactly we will write over FIO pin. Then in hardware also, it will find its reflection. So logically you have done it through FIO pin, but obviously we are dealing with hardware. So then your system will understand it through FIO pin. Then system will change it automatically. We don't have to worry. So we are dealing it through logical construct, but that logical construct is finding its expression through hardware. The system is making that way for us. That is regarding FIO pin. Suppose so FIO pin would be handy that if all 32-bit locations you want to change in one go, then you can do it through FIO pin. Suppose selectively in individual bits, you want to FIO set. What is FIO set is used for? Suppose any particular pin, or not a particular single pin, several pins also out of those 32, you want to set as high. You want to set those pins with value 1. Then in FIO set corresponding to those pin locations for that particular pin, if you will make the value 1, then in the subsequent cycle, system cycle, your controller or processor will make those particular pins and set those particular pins as 1. That is the importance of FIO set. Reverse of it is that you want to make those pins as 0. That is called clearing those things. whatever is the current value, you want to clear it. You want to make it 0. In that case, in FIO clear register, particular pins, if you want to clear or make their value as 0, so in FIO clear, corresponding to those bit location in FIO clear register, the value should be 1. If the value should be 1 in the next subsequent system cycle, those particular bit location corresponding pins will be 0. System will do it automatically. Now, if you want to mask certain pins over which FIO pin, FIO set, and FIO clear will not function. Suppose through FIO pin you want to change the value, through FIO set you want to set certain value over the pins, through FIO clear you want to clear certain pins, but certain pin information you want to keep for future reference. You don't want any of these registers to change those values. So you want to protect it from FIO pin to change the value, FIO set to set it as high, FIO clear to set it, means to clear it. Then corresponding to those pin locations in FIO mask register, we'll set the value as 1. Once you will set the value as 1, they will find protection from FIO pin, FIO set, and FIO clear. Then these 3 things will have no impact over those pins to change their value physically, through hardware. That is all about FIO mask. Why do we require? So over a period of time, if you want to preserve certain value over the pin, then we can do it. We can use FIO mask. Then even by mistake in program, you want to change through FIO pin, FIO set, FIO clear, will not find hardware reflection. So that we can do through FIO mask. So these are 5 registers. Now we will understand the importance of these 5 registers. So the slide I will share with you. Now I will go through the programming tutorial, general purpose input output programming tutorial. We will use the structures, C structures. So in general, we will use C. And whatever we will write, that also has another name attached to it, that is called embedded C. Because later on, whatever we will write in C, we'll make a hex file out of it, and then that thing we will embed in our kit. We will load that thing in our kit ROM, and then that functionality will find its hardware reflection. That's why it is embedded C. So for that purpose, we require LPC17XX.h because our kit is NXP17 LPC1768. So all the structures, whatever the structure corresponding to these ports and their registers, whatever we will use, already everything is defined in LPC17XX.h. There are several variants. We will use LPC1768. So that header formats, everything is based on Cortex microcontroller system interface standards. Don't worry about these things. Everything is self-explanatory. At least the naming convention is self-explanatory. So like suppose we want to use port number 0 and several pins are also there inside port number 0. So there is one defined structure, LPC Gpio 0, general purpose input output 0. Inside that, to control all the pins, we have several other registers. So all other registers are the part of this structure, LPC Gpio 0. Likewise, 5 register means 5 ports are there, Gpio 0, Gpio 1, Gpio 2, Gpio 3, and Gpio 4. So that is the naming convention. which is there defined in LP17 access.h that we will use. That is a simple C structure, nothing. Already we have understood FIO direction, FIO mask, FIO pin, set and clear. Now in pin select register, you know the importance of pin select register. Now we will understand it through certain programming constructs. Suppose we have a pin 3 on port number 0. We want to configure it as an output pin. So port number 0, pin number 3. So port number 0, when once port number 0 comes into picture, and pin number 3. So pin select 0 we will use. So pin select 0 we will use. By default the value is 0, but explicitly also you can make corresponding to pin number 3. So pin number 3 means position number 3 to the 6, 6 and 7. 6 and 7 should be 0, 0. If some other value would be there instead of 0, 0, then that pin would not function as general purpose input output. But that is by default. That is not our concern. Once you will start, by default, every pin is configured in every port as GPIO pin. Now, our aim is to make it as an output pin, because if you will go inside to GPIO 0, FIO direction register. In FIO direction register, initially all values are 0, 0, 0. All values are 0. All 32 bit positions are 0. So everything is input. Explicitly, we have to make pin number 3 as output pin. So pin number 3rd. So bit number 3rd. We are using the naming convention starting from 0. So bit number 1 we are naming as bit 0. That is the bit 0 location, 0th location, first location, third location, fourth location. So pin number 3 is third pin. So third location should have the value 1. That's what we are doing here. You can see 1 left shift 3, and that you are directly writing to FIO direction. That is one way. How in another way you can do it? You can XOR, and not XOR. You can OR it with 1 0 0 0. So 8 means, so in hexadecimal it is 8, but if you will convert it into decimal, then 1 0 0 0. So third position if you will start from 0 position, first position, third, second position. So till second position everything is 0. Third position is 1, and that you are pouring it with. So initially, even though 1 is there, 0 is there in FIO direction register, finally ultimately you will get a value 1. That is our ultimate aim. So in any way you can do it. Third one is you are first left shifting 1 by 3. That means you will get the 8 value in hexadecimal, and that you are then pouring it with the FIO direction register. So third position will find the value 1 after the execution of this instruction. In any of these ways, you can use any of these ways to actually write the corresponding value which you want. That is one thing. In second case, consider that we want to configure port number 4, pin number 4, port number 0 as output. So direction, and then we want to set it as high. So FIO set register we will use. Here you can use FIO pin as well. Making output configure 17, pin number 17 as high or port number 0 and then low. So first to change its direction. So because it is an output pin, then you want to set it as high. So set it using set and clear it using clear. Simple enough. Now we want to configure port number 0 and 0. So 5th and 11th pin, both we want to set as input output, and then we want to set both the pin. So in one instruction you can do so. First 5th 1 left shift by 5 over it with FIO direction, then whatever the value comes next, 11th position shifted by 11 and then over it, and then same way FIO set. So this is all for you to understand that how you can play with the bit positions, why to play with the bit positions, what is the importance of these 5 registers. So for general purpose input output to understand, you have to thorough with the understanding of pin select register. Then you have to be thorough with the understanding of FIO direction, FIO pin, FIO set, FIO clear. FIO mask is also there, but rarely we will use FIO mask. But these 5 registers, you should be thorough. Pin select register, so in total 10 pin select registers are there to actually configure port pin. 4 functions are there to choose any one of those functions. We have pin select registers, and then we have FIO direction register to set the direction, FIO set register to set any of the pin as 1, FIO clear to clear it to make it 0, and FIO pin to read the value, what is the current status, or even through FIO pin you can change the values over the pins. That is all about general purpose input output. Now while writing the program, depending on our requirement, we will configure certain pins out of the total 70 pins, because those 70 pins can be configured as general purpose input output. Out of those pins, we will configure certain pins as general purpose input output. We will use those pins. Then those pins obviously would be the part of port. Corresponding to that port, we have 5 registers, FIO direction, then we will set the direction depending on our requirement. Some pins we could have a requirement for input, certain pins we will use for output. So how we will decide input and output pins? If certain pins will get input and your system is looking for that input from other peripherals, so those pins we have to configure as input pin. Some pins which we will connect to other peripherals, and those peripherals will receive those output as their input. So always input and output we have to consider, we have to understand with reference to system code. So system is looking for certain input. So that particular pin we have to configure as input pin. System will write over the pins so that your controller can take those outputs as input. I mean, not controller, your peripherals can take those output as input. Then those pins we have to configure as output pins using FIO direction registers. Now, over a period of time while writing program, that comprises of our logic, that how we will change the value over a period of time, when we will make those output pins 1, when we have to make those output pins 0, in what order we will make the changes. That all depends on the logic. So in next video, I will discuss about those programs. So based on the requirement, how to control the peripherals. So our system will control the peripherals through general purpose input output programming. So we will write our C code, we will embed that C code in our gate, and then once you will power supply and run the program using controller, you can control your peripherals, you can control other peripheral modules that we will understand. Hope you have enjoyed the video. See you in next.